Here's a problem on linear algebra. So here P subscript AX denotes characteristic polynomial of matrix A, and we have to tell for which of these options this Pmx minus Pm inverse of x is a constant, where M is any of these matrices. All right, so let's solve this. So M here is a 2 by 2 matrix. So Pm of x is nothing but x minus alpha, x minus beta, where alpha, beta are just the eigenvalues of M. These are okay. And what will be eigenvalues of M inverse? Well, they will be 1 upon alpha, 1 upon beta, right? So what can we say about Pm inverse x? Well, it should be x minus 1 upon alpha times x minus 1 upon beta. So Pm of x minus Pm inverse x equals this minus alpha plus beta x plus alpha plus beta upon alpha beta times x, right? Plus alpha beta minus 1 upon alpha beta. Okay, now let's take a look at these options. What is alpha plus beta here? For option A, alpha plus beta is sum of eigenvalues, and we know that the sum of eigenvalues is equal to sum of the diagonal elements, so this is equal to 8. And what is alpha times beta? Well, this is the determinant of this, and determinant of this is nothing but 1. So here, alpha beta becomes 1, and these get cancelled, so we are left with only a constant. So option A gives me a constant, so this should be correct. What about option number B? Well, for option number B, alpha plus beta becomes 5, and alpha beta becomes 2. So if we plug these values here, we get minus 5x plus 5.2 x plus 2 minus 1, 2. And this is clearly not a constant. So option B is incorrect. What about option number C? Well, in option number C, alpha plus beta is 0. So this term goes to 0, this term becomes 0, and we're left with a constant. So option C is correct as well. Option number D, well, because of the same reasons as in B, I think this should not be correct either. But let's check it again. So alpha plus beta is 2, and alpha beta equals to 1, right? So here alpha beta is 1, therefore this quantity gets cancelled by this quantity, and we're left with only a constant. So this is correct as well. So the correct options are A, C, and D.